Hello, this is the first lesson of Unit 2. This is day 1, equations of a circle. Unit 2 is going to be talking about circles and pretty much the whole thing. So we start out by kind of linking it with functions and the calculator. We're not going to use the calculator that much, so I'm going to go ahead and minimize that for now. A couple things that I want you to memorize going into this unit and next unit is area formula and circumference formula of a circle. So I'm going to write these on here. You might even know them already, but just in case, area is pi r squared. Circumference of a circle is, there's two ways to look at it. You could do pi times diameter, pi d, or you could say 2 times pi times r, because remember the diameter is just twice the radius. So they're both the same. I want you to memorize these formulas before the end of the unit. Got it? Remember that in a circle, the radius is the distance from the center to the edge, and the diameter is all the way across. So let's get started with the equation of a circle. I'm going to go ahead and give you the formula. It's parentheses x minus h, close up parentheses with a square, plus parentheses y minus k squared equals r squared. If you look at all those squares, you might recognize something that we've used squares before similar to that. Pythagorean theorem. And really all this is in a circle is if you make a triangle with the lengths that are given to you in here, it's basically going to form a right triangle. And so it comes from the Pythagorean theorem, just like the distance formula does as well. The center of the circle is a coordinate. It's going to be some numbers, and it might be negative or positive, but it's just a coordinate. And so whatever represents h and k, those numbers represent the center of the circle. And the radius, of course, we just define as r. So if you see a circle on a coordinate plane, wherever that circle is, the center, that coordinate will be at that point. This will be h and k. And then the radius is the distance from the center to the edge of the circle, going either left, right, up, or down. Wherever you can get that distance, count those spaces, that's the radius. So that's the equation of the circle. You want to memorize that too, along with area and circumference formulas. So here's how you write the equation. So we'll start with given the center. This is your center. This is h and this is k. And your radius is 5. So if you simply just plug it into the formula, remember that's your formula, you'll have x minus 2 quantity squared plus parentheses y minus negative 3 quantity squared equals 5 squared. We like to simplify that a little bit. So the x minus 2, that's cool. You know, it changes the sign of the 2 because there's a negative in the function, but you don't have any double signs, so we don't have to worry about changing that. We're not going to bother squaring this out. We're going to leave it as x minus 2 squared. But we don't want to write minus negative. And we don't want to leave that as 5 squared. So I'm going to clean this up just a little bit. X minus 2 squared plus y plus 3. Remember, subtracting a negative is adding a positive. So plus y plus 3 squared. And then 5 squared is 25. So the answer you want to give for this is right here. And this is an optional step. You don't have to show this step if you know to switch the sign here and square the radius. Otherwise, show the steps so that way you can always get it correct. Example 2, we want to go the other way. So this time we're given the equation, we want to get the center. So if you think about the formula x minus h squared, y minus k squared equals r squared. Well, if this is x minus a number, and the formula has x minus a number, then h is going to be 4. If there's no number here, that's the same thing as y minus 0. So k will be simply 0. That's the y coordinate of the center. And because this number here represents radius squared, the radius is going to be the square root of 95. Since 95 isn't a perfect square, I'm going to leave that as the square root of 95. I'm not going to bother getting a decimal for that and making it worse than it has to be. So when I write my answer, my center is going to be 4, 0, and my radius will be the square root of 95. All right, you got that? All right, moving on. All right, so you want to take a second to try these on your own first. So at this point would be a good time to pause the video. And once you've tried them, unpause it and watch me work through them and see how you did. Okay, hopefully you got a chance to work them out. The way that you would work out example 1 for the your turns, it says write an equation with center at 0, 0, and radius the square root of 3. So if I plug it in the formula, x minus 0 squared plus y minus 0 squared equals the square root of 3 squared. That is technically correct, but we do want to make that simplified. So anytime there's a 0, we just don't write it. We just say x squared plus y squared. Now what is the square root of 3 squared? Well, that's equal to the square root of 3 times the square root of 3, which is the square root of 9, which is 3. So anytime you're squaring a square root, it's just going to cancel that out. So you're just stuck with the number 3. You don't have to worry about any square roots or anything like that there. We're just going to say equals 3. Now, number 2 for the your turns, we get the center here. You'll notice that it's x minus again, so the h value is going to be 2. The k value, again, there's no number, so it's going to be 0. So that's your center. And then this is r squared. Remember that. So to get the radius, we want to square root the 35. Okay. Now we're going to have to graph these as well. Now it would help to have a coordinate plane, so you might want to have some graph paper on hand unless you can sketch these pretty accurately without it. So I'm going to go ahead and put some grid lines on here. All right, to graph the circles, you know, again, it helps to have some graph paper, but I'm going to draw some solid lines to represent an x and y axis. And let's get our center first. So our center is going to be, from the formula, this is going to be 3 and 4. The center is always the opposite of these signs, so if these were both positive, then the center would be negative 3 and negative 4. The radius is the square root of this number, so the square root of 4 is 2. So the first step to do this is you want to plot the center. So you want to plot 3, 4. So go right 3, 1, 2, 3. go up 4, and that's your center. That's actually not on the circle. That's inside of the circle. But we use that to count out the radius. So since the radius is 2, we're going to go in 4 directions. We go out 2, put a point there. If you had a compass, you can make this real nice. Go up 2, go left 2. Again, we're coming from the center, so going left 2, and we're going to go down 2. And you want to draw the best circle you can around those 4 points. And so this represents your circle. You'll have the grid lines in here. Mine just covered it up. But when you graph that, you get your circle here, mark your radius. That's 2 units, whatever the units are. And the center is 3, 4. You can write that on here, but it's hopefully pretty clear on the graph that that's the center at this coordinate 3, 4. So this would be your answer right here. I'm going to graph that. All right, moving on. We're going to use 2 formulas that hopefully you are familiar with. We've used them a couple times before, midpoint and distance. So I'm going to go ahead and write those on here. You want to memorize these by the end of the unit as well. So the midpoint is x1 plus x2 over 2, comma y1 plus y2 over 2. Remember, that's a coordinate, and it's the average of the x's and the average of the y's. We use this to get the center. The distance formula is the square root of, that's an awful square root, hold on, let me clear that up. The square root of x parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. We use this to get radius. So we're going to be given coordinates on the circle, or we're going to be given the center and one of the points on the circle, and we're going to have to use these formulas to get the radius and get the center in some cases, so that we can write the equation. All right, so write these down, and let's get started on those examples. All right, the first example, the endpoints of a diameter of a circle are 1, 3, and 5, 5. Write the equation of the circle. So the endpoints of a diameter, if you imagine a circle, and if I plot the points 1, 3, I'm not going to make a nice graph here, but if I plot the points 1, 3, and 5, 5, imagine that this is the diameter of a circle, and the circle is going to look something like that. Now, it's not a very precise circle, but you get the idea. So the goal here is find where is the center, and once we get the center, what's the radius? If I know those two things, I can write the equation and answer the question. So we can estimate the center on this, just by using the midpoint. Actually, if you just think about these two numbers, 1 and 5, what's halfway between 1 and 5? There's not a lot of choices here. This is going to be 3, and halfway between 3 and 5 is 4. So that coordinate, if I drew right correctly, which looks somewhat accurate, should be 3, 4. Now I'm going to use the midpoint formula to get that and confirm that. So the center is going to be 1 plus 5 over 2. Remember, x1 plus x2 over 2. Here's your x's. And y1 plus y2. 3 plus 5 over 2. So if we check that out, that's going to be 6 over 2. 6 divided by 2 is 3. And that's going to be 8 divided by 2. That's going to be 4. So you can get the midpoint using the midpoint formula, and in some cases you can look at the graph and get that too. But anyway, that's your center. Now to get the radius, we want to use the distance formula. So what we're going to do is we're going to find the distance between the center and one of these 2 points. It doesn't really matter which point you use because that radius is the same. So I'm just going to use the point 5,5, but you could have easily used the point 1,3. What we're going to do is we're going to get the distance between the point 5,5 and our newly found center, which is 3,4. We're going to plug those into the distance formula. Remember, the distance formula is x2 minus x1 squared, so that'll be 5 minus 3 squared, plus y2 minus y1 squared, so the quantity 5 minus 4 squared. And after we square them and add them, we're going to take the square root. So that radius, I should have written r, but that distance is the radius. That's going to be 2 squared plus 1 squared. And again, you can use your calculator if you want to, but I find just breaking this up individually gives you a little bit more accuracy in your answers. So that's going to be the square root of 4 plus 1. 1 squared is 1. So that's the radius is the square root of 5. Now that I have my center and my radius, I'm ready to write my equation. So my equation, which is what you want to report as your answer, is going to be parentheses x minus, remember this is h and this is k, so x minus 3 squared plus y minus 4 squared equals the square root of 5 squared, r squared. Now, I would accept that, but I would like to see the square root of 5 squared simplified to just 5. So I'm going to write my final answer as x minus 3 squared plus y minus 4 squared, and we don't have to change those because they're not double negatives, is equal to 5. So the equation of the circle is the answer. That's what you want. All this is just the work to get you there. You don't need to graph it. That was just a visual for you, so hopefully it was a little bit more, it made more sense looking at the graph, but you don't need to do that. But you do need to get the midpoint and the distance between the center and the edge of the circle. All right, one more example. All right, you might want to pause this and try this on your own. We'll come back to it after you've given it a shot, and you can look at my instructions on how to do it, and hopefully it matches up with what you did. All right. So the question is a circle whose center is at the origin. What coordinate is the origin? 0, 0. So that's your center. That's your h and that's your k. It passes through the point 6, 8. So we have the center. We don't need to do midpoint. We only have one of the endpoints of the diameter. We don't have the other one. So we're not going to do the midpoint and cut that in half. Think about it like this. The center of your circle is right here. It goes through the point 6, 8. But it's going to go around. See, I don't know what the radius is. But it's going to go around that center. And I don't care about this point. I just need to know, what is that distance? What is that radius? So the only thing I really need to do is use the distance formula. Okay, so the radius is going to be the square root x2 minus x1 squared, so 6 minus 0 squared, plus y2 minus y1 squared, so 8 minus 0 squared. 6 minus 0 is 6, so 6 squared is 36. Always write your square root, so this is going to be 6 squared plus 8 squared. 36 plus 64. Give you a chance to use your calculator to try that out. Should give you the square root of 100. Hey, 100 is a perfect square. What is the square root of 100? There's my radius. That's going to be 10. So you have your center and you have your radius. We're all set to write the equation. And so the equation is going to be parentheses x minus 0, remember that's the h part, squared, plus y minus 0 squared equals 10 squared. And we really don't want to write those zeros, and we want to square that number. So we're going to finalize this as x squared plus y squared equals 100. And that is your final answer. Again, I hope this was helpful for you, and you want to try the Unit 2 Day 1 assignment using these notes. Thank you, and as always, if you have any questions, come ask. Don't hesitate to ask. Thank you.